Thank you. So what I want us to do today is to try to expose you to the concept of estimations and hypothesis testing. That's what we want to try to look at. So as you can see, these are examination questions. I will not go over these things like mode, whatever, those median. We already talked about this. My area of interest is on question number B. Question number B. So I'll focus on question number B because that's my focus as for today. So question number B says, a plant manager claims that the mean number of calories per 10 kg can of tomato paste is just 150, and a random sample of 170 cans gave a mean of 157 or 54 calories, and the standard deviation is given to be 20 calories. Then you have to explain how one can commit a type 2 error in that context. So first of all, when you're talking about hypothesis testing, you're trying to test the validity of the claims that are there. So take, for example, there are some existing statements that you might have. You can have a statement. You can't see the screen that I'm sharing. Analysts can't see.
I can now, sir. Thank you.
Okay.
Thank you, sir.
All right, thank you. All right. So I was saying that in hypothesis testing, what is there is that you have the claim, the existing statement. For example, here. So the existing statement is that the plant manager claims that the mean, which is the average number of calories per 10 kg can of tomato paste is what? Is 150. This is what the manager knows, and this is what we know in the meantime, right? So I said that the existing statement is known as the null hypothesis. Is said to be a null hypothesis, H naught. It means that that's the existing statement. So what we have is that the null hypothesis is that mu, the population mean, is equal to what? To 150. That is what we have now. Then there is a statistician or a researcher or somebody who is inquiring who wants to test the validity of this statement. Okay, so what they do, they want to test if this is true, that per 10 kg, okay, the mean of calories is what? Is 150 for tomato paste or of tomato paste. So what this statistician has done, he has gotten a random sample of 170 cans. That's a sample size. He has gotten the sample of 170 cans, and he has calculated for the mean now. This is the mean from the what? From the sample. So when he calculated for the mean, he found out that the mean was 154. Okay, he found out that the mean was 154. So what are we supposed to do now in this case? Given this, we are also given that the standard deviation is what? 20. That's our standard deviation. So there are basically about 4 different methods of testing the validity of the statements that are there. You can use the Z value that follows the normal distribution. You can still use the P value. You can still use the, okay, let me write them down. I was saying that you can use the Z value. You can use the P value. You can use the P value. From the p-value, you can use the confidence interval. Okay, you can use the confidence interval. What we call the confidence interval to test the validity of this statement. Okay, you can use the confidence interval to test for the validity of this statement. In this question, we use both of them. We'll try to use both of them so that you can at least be able to have the idea of what is going on. So now, let me start by introducing you to the concept of confidence interval. How do we use the confidence interval to test for the validity of the following the following statements? Okay, so under the confidence interval, it is given that, okay, when you're using the confidence interval, it is given that the confidence interval will be X bar, which is the mean from the sample. That should be plus or minus the z-score, alpha, which is the significance level, divided by what? By 2. That is for the double-tailed data distribution. Don't worry, just yeah, don't worry, just follow enough. I know you might find it difficult to get. Just pay attention. You will understand. Just follow. Then what we have is to multiply this by the standard deviation over the square root of n, which is the sample size. So this is the formula for finding the confidence interval given the mean. Right. So I've gotten the request to go over this, and I'll go over this quickly. What we are trying to do is to do hypothesis testing, right? We're trying to do hypothesis testing. We have a question that we have here from the exam. This is of course, these are answer questions, the questions from the University of Zambia. So the question that we are answering is question number B. There is a claim from the manager that the mean number of the calories per 10 kg can of tomato paste is 150. This is what is known. Then you want to test the validity of this statement. You want to examine, is this true or false, right? So you go ahead, you collect the sample of 170 cans, and then you calculate for the mean. You find that the mean is what? 154 calories, and you find the standard deviation to be 20 when you did the calculations from the sample that you sampled. So I was saying that for you to test now the validity, whether this statement is valid or not, there are different methods that we use. Number one, we have what we call the z-value method, or the z-score, which follows the normal distribution. If the data is following the normal distribution, you have the p-value, and you have the confidence the confidence interval method, where you need to create the confidence the confidence interval, okay, which is basically more like the range. It's basically the range in which we need to examine if this hypothesized value, this 150, it falls within that range. If we find that this 150 falls within that range, then it means we fail to reject, right? We do not reject if this contains the hypothesized value, the region, this interval. So I was saying, to find that interval now, I've skipped first the part 1, which says explain how one can commit type 2 error. I'm still concentrating on how to create the confidence interval. Just follow nicely. So this is the formula for the confidence interval when you're given the mean. Okay, so it says that the mean from the sample, which is X bar plus or minus Z score. This is a certain value. This is a critical value. Okay, Z score, that is that is from the alpha over 2, which is the alpha is the basically the significance level. Then it should be multiplied by what? By the standard deviation over the square root of n. So this is basically the formula for the range. I'll start explaining now the meanings of each element and how you find each element. So just follow nice. I'm not just rushing into answering the question. I'm trying to teach using the question. So just follow. So what is there is this now. From the data sampled or from the data collected, I want to explain the meanings of this now. X bar, this X bar, it is the mean that you get when you have calculated what when you have sampled the population. It's a mean that is coming from the population that the statistician got or the researcher. We found it to be 54. Then this plus or minus, it is helping us to create the range that we are going to be creating. You see the range that we're going to be creating. Then this is Z score. This is Z alpha. It's basically a critical value, okay? It's the critical value. I'll show you how to get this critical value. You get it from the standard normal distribution table, okay? Yeah, for today, I'll use, I think I'll use that same one you had in your test so that you can also know how to read that table. Yeah. So this one is basically coming from the table. Then the standard deviation is given. It is in the question. And the square root of n is the sample size. How huge the sample is that you selected. You found that you selected the sample of what? 170 cans, right? I think I've tried to define these parts and what they mean. Any question here? We are not rushing. We still have time to the exam. We just want to make sure that whether we have learned 2 topics or 4 topics, we are able to answer them. Do I have any question? Hello? But am I
Excuse
audible
me,
enough?
sir. Excuse
Yes,
me, sir. Yeah, come again on the last part. I didn't get I didn't get clearly.
Okay. Okay. On the definition of these, the formula, how the meanings of these things on the formula.
Yeah, I think I'm okay there. So on the formula and the interpretation itself.
Oh, okay. No, all right, we'll come to the interpretation. Don't worry. I was just trying to define the parts of these elements in the formula. That this X bar is basically the mean that you get from the sample, okay? Not from the population, but from the sample. Then this is Z multiplied by alpha over 2 is basically the critical value. I'll show you how you find the critical value. I said that it is coming from the standard normal distribution table. We'll show you how to extract this value. Then the standard deviation, this one on top here, this one is the standard deviation. It is given in the question that it is 20 calories. Then what's this? The square root of n. N is the sample size. The sample size is given to what? 70. We are told that the sample size is 170. Yeah. Did you get that?
Yes, I picked that one.
Okay. So the question that we are answering is question B2. That's the question that we are trying to do. Okay, we are trying to do question B2. Question B2, which says, can you construct a 99% confidence interval of the true mean number of calories per 10 kg? So now, we know that when you add the confidence interval, let me just say CI, the confidence interval plus, which is this is just the confidence level, plus the significance level. The significance level, it should be equal to what? To 100%, right? So if we are given that we are to construct a 99% confidence interval for the true mean population, true mean number of calories, it means that if we have the confidence interval as 90 what? As 99, then we can easily calculate for the what? For the significance level, because what we are interested in is the alpha. The alpha is the significance level. So confidence interval, let me say it like this. Our alpha is the significance level, right? So it means to find the confidence interval, we will say 100% minus what? Minus this alpha. If you leave alpha into decimals, okay, I am saying that this significance level is alpha. That's our alpha that I meant. Significance level of significance. Then confidence interval will be found by saying confidence interval shall be 100% minus what? The significance level, which is our alpha, right? Yeah, that will be our confidence level. It will be 100% minus what? Minus our alpha. It will give us the confidence interval, which applies the same. If you're looking for alpha, it means you say just alpha shall be equal to what? To the confidence. How do we get the alpha? We will say 100% minus what? This confidence interval now. It will give us alpha. This confidence interval. It will give us the alpha, which is the significance level, the level of significance. That is how significant is your what? Is your how significant is your research? Okay, as a researcher, you have collected data, you are to make the analysis, and you're making the analysis. Then you want to stand up and say, no, this claim is wrong. Remember, you are disproving a certain claim. So you want to say this claim is wrong or is correct. Okay. So now the question is that how significant is your claim now, you as a researcher? So the level of significance is given as what? As your alpha. That's the one that we are talking about. So if you are able to reject the null hypothesis or to prove wrong, okay, that is to prove wrong what they have said, then it means your research is more significant, right? It's significant. You've managed to disprove. That is to prove wrong what was the claim that is existing. Okay, so that is what I'm trying just to introduce you to. Okay. So now, since I've said that in the calculations of this confidence level, like in the constructions of the confidence interval, we just focus on what? On alpha, not on the confidence interval. Like on this 99%, which is this 95, this 95, the 99% is not the that is. It's not the level of significance. So we concentrate on the level of significance of alpha. Yeah. It's basically our confidence level. So how do we do it? Our confidence level is 99%, but what about the level of significance? It should be 100% minus 99. That should be 1%, right? 0.01. Isn't it? It shall be our significance level. Our level of significance will be alpha will be equal to 0.01. Okay, which is same as 1%. Hello.
Sir.
Following, sir.
Okay.
Hello.
Hello.
So you're saying our significance level, which is the alpha, is supposed to be 0.01?
0.01 or 1%, but you need to write it as a decimal.
Okay, so you're not supposed to find anything more than this.
Okay, you remember that you are subtracting it from this 100. 100 minus this confidence level. Your confidence level is 99%, right? Yes, your confidence level is 99%, which means your significance level is 1%. Okay, because
okay.
confidence level plus significance level should be equal 100%. Did you
Okay.
get that?
Yes,
All
I
right.
did.
Yeah. So from here now. So remember we said that if it is a double tail, you have to divide this alpha by 2 to find the z critique, right? I'm concentrating on this element now. Z alpha over 2. Why should we divide by 2 this alpha? It's because if they say that the mu, the hypothesized mean, is equal to, it means the alternative hypothesis will be not equal to, which can be either less or greater than that, right? Your alternative hypothesis HA shall be what? The mu shall be not equal to what? To 1/5, which means if it is not equal to 1/5, it can either be greater than 1/5 or less than 1/5. That's the implication. So that's why we say this is a double what? It's a double tailed. If we were to graph this, let me show you the graph. Remind you the graph. I think we had such discussions during the residentials anyway. If we are to graph this data is normally distributed, right? Normal distribution here, what you had last time. The critical value that I'm talking about, this is Z alpha over 2 will be here. Even this side will have negative Z alpha over 2. Why should we divide by 2 this significance level? It's because it's 2 sides, okay? Like this significance level is on 2 sides. It can either be on the positive side here, significance level alpha, or also this side. It can also fall this side. That's why you divide by 2. So that when you divide by 2, 0.01, what do you get when you divide this by 2?
0.005.
Okay, so this will be 0.005 as our alpha. So our significance level will be equal to what? 0.005, right? 0.005. That's our alpha this side. So that even also this side, check, even also this side, we can also have what? Alpha that is equal to 0.005. When you add these two, it will be 0.1. Then plus this region in between. This region in between is what? Is 99%. So this is 1%, like 0.005 plus 0.005. It gives us 1%, right? 1% plus 99%, it gives us 100% here. So that's the graphical, more like some graphical representation of this. Are you able to follow?
Sir,
Madam.
I wanted to find out, how do you tell in a question that this is supposed to be a double-tailed?
Oh, okay. When you get the question like the way how it says that the mean, okay, the hypothesized value, in this case, it is the mean. The mean, the hypothesized value is what? Is 150. Once you find the word is, it means it is equal, right? Means equal. So it means it is equal. Therefore, your alternative hypothesis of what? It is not equal. You get it? When you're forming the alternative hypothesis, you say it is not equal. If it is not equal, then it should be double-tailed because it can be either greater or less, right? If it is less, that will be negative side. If it is greater, that will be on the positive side, right?
Oh, okay, I get it.
But if you find that they say that the mean, for example, a plant manager claims that the mean number of calories per 10 kg of tomato paste is more than 150. Have you gotten the way how I've restructured the question? It's more than 150. So that simply means now it is not equal to 150. It's more than 150. So therefore, it is what? It means that I'm seeing the hand. This means that this is a right tailed, like your mean is to the right, right? It's greater. So it means that this data is distributed to the right or to the positive side, which is the greater side. It is like this, it's a single tail to the right. Did you get that? Before I can get Chisha Kalunga.
Yes, I've gotten it. So if it's one-tailed, meaning we're not supposed to write the z-score alpha over 2.
No, you don't divide this alpha now. You
So
just
how
say
do we write it if it's symbol?
z-score alpha. It will be z-score
okay.
alpha.
Okay, sir.
It will just be z-score alpha. Chisha, I can see your hand.
Yes, sir. Firstly, apologies.
It's fine.
I don't know if it's my network. I kept being logged out at some point, and the last thing that I left was the 0.01.
Oh,
So,
okay. Okay. All right. So I was saying that this 0.01 is the significance level, right? It's a significance level. So being the significance level, we mean that what we mean is that since this is a double-tailed, okay, it's a double-tailed, this data is distributed, it gives us a double tail. It is distributed both, it can be distributed both to the right and the negative, or which is the left. Then you divide this alpha, which is 0.01 by 2. When you divide this alpha 0.01 by 2, it will give us this critical value here. It will help us to get the critical value here when you go to the table. We haven't gone to the table. I'm just showing you so that when you go to the table, you understand what is going on. So this will just help us to, it will just help us to get the critical value from the table. And that critical value, very, very critical when we are forming the confidence interval and when we are deciding whether to reject the claim or accepting the claim. So we have basically divided this by 2. And once we divide this by 2, we find these values, 0.005, which is also this side. So that when you add these two, they can give us 0.1, and you add this 0.1 to 99%, you get 100%. 0.1 is same as 1%. Did you get that?
I hear you.
Hello.
I hear you, sir. Thank you.
Okay. Right. Yeah. Don't worry. We will do as many questions as we can. Yeah. I know always once you're receiving some new information, I don't know whether it's the network which is being difficult. Some people are logging out. I don't know. Anyways, so what you do, it can sound that confusing as we are beginning, but just endure and be able to follow. You will understand. I know with more examples, you'll understand. Just follow. Okay. So I was saying that. So what is there is we want to find. We have found our alpha to be 0.005. So when you want to create our interval, our confidence interval, I said our confidence interval will be x bar, the mean plus C or minus C. This critical value here, which we'll find, we're going to find it from the table, alpha over Z, which is 0.005. I'll show you how we get this one, times the standard deviation over the square root of the sample. You multiply these two. Then it will help us to find the interval. So let's start from the mean, x bar. What is our x bar? We had found our x bar to be 170, isn't it? The sample mean. The sample mean is it 154, right? 154. The sample mean is 154 plus or minus. Then before we find this one, because this one we find it from the table, let's put the standard deviation. What is our standard deviation? It is given in the question.
20.
It's 20, right? It's 20. And the square root of the sample. And our sample size is what? 170, right? We're following that time. Hello.
Yes, sir.
So how do you find this now? This is Z, this critical value that I'm talking about. So you need to know how to find the critical value. So how we find the critical value? You simply need to go to the table. Okay, you need to go to the table. But for today, I want to show you how to read that table. That table you had in your visited test. So you're going to look for the significance level. That table was giving the values to the right.
Hello, sir.
Hello.
Sorry, I want to find out before we proceed so that I can follow you keenly and clearly.
Yes, sir.
On the Z-score, we are saying, according to this question, this is a double-tailed graph, isn't it?
Yes, sir.
And for us to have the Z-score, we need to divide mu by 2. So kindly confirm if it was a single tail, then the critical values. Okay. If it was a single tailed, kindly confirm then the Z-score would be equal to mu or alpha.
I don't know if I'm getting your question. You said if it was a single tail,
yes,
the Z-score would be equal to
alpha. Alpha.
Yeah. So if it was a single tailed, we wouldn't have divided. So our Z-score would have just used the alpha like this alpha. That's the one that would have used it to get the critical value. Remember, this is not just the final, like 0.5. This alpha is not the final answer to put here. It is just helping us to get it from the table where we are going. Yeah, it's just helping us.
Okay, noted.
Okay, so yeah, it is just helping us to get the value that we are looking for. So now we have established that this is a double, it's a double-tailed. So it means our alpha is 0.05. Our alpha is 0.05. So this is our alpha. We want to get, this is the area, right? This is the area. That is after, if you follow that table that you had, which was giving the areas or the probabilities to the right of Z-score, the Z value. This is the critical value, right? This is 0.05 is here, is after this critical value. If you follow the standard normal distribution table, that gives the areas after this critical value. Then you're going to go to the table and look for the what? For the critical value that corresponds to this area. Because this area that is after this critical value is, we have said it is equal to alpha, right? Which is 0.05, which is 0.05. So we're going to find the area. This is the area, of course. We're going to find the critical value that corresponds to this area from the table. Did you get that now?
Yes, sir.
Okay. Then we can move. We can move. We get it. We can move. So our alpha is 0.05. Let's go to the table. Where is that table? Where was it? We want to get that critical value. I want to show you how we get that critical value. 0.05. The standard normal distribution table. Where is it? Okay. It should be in statistics. Yeah, I know it's the first time. It might sound that difficult to get, but you'll be fine. I know. Just take calm. You'll be fine. Yeah, following this table, that these were the formulas that you had. So how do you get that alpha, that critical value using this table that you had? Oh, this is it. This is it. Okay. Are you able to see the table?
Yes.
Okay. Let me if you have looked at the table critically, this table is defined that it gives the probability or the percentage to the right of the z-score, right? So all the areas that you're going to get are those areas that are represented by alpha, in short. Because we know that alpha is always after what? After the critical value, right? So we are getting the areas that correspond to alpha. So that is what we are going to do. We're going to get the areas that correspond to alpha. So we are looking for that area 0. At what was it? What was our alpha again? 0.005, isn't it?
Yes.
That was our alpha. That was the area. So we are going to look for 0.005 here from the table here. Where we are going to find it, we are going to locate it. 0.005. Are we able to locate it? 0.005.
It's where there's 3.3 on the z-score.
3.3 and then
3.3, yeah.
Or
That's where it's located.
3.3.
Yes,
Yes.
on the z-score.
In the first line.
Or 3.3. These are many. These are triple zeros. Check, these are triple zeros. This is 0.000. Are you able to see? But these are 2 zeros.
So are we not supposed to use the other table, the last one on that paper you're using? This is the list we're given in class, right?
Yeah.
Are we not supposed to use the last page, the table on the last page? No.
What do you mean by the last page? Because this is the
table.
You are supposed to use the standard normal distribution table. Then do the other standard distribution table. Let's check. This is the chi-square table. This one you have is a chi-square. Then this is the t distribution table. You've seen this one is for the t. This is the t1. This is the last table. This is the t distribution. That one who is asking about the last table. This one is the t distribution.
0.05.
Okay. And you use the t. You use the. Oh no. So now listen. The t distribution, you only use it when the sample size is less than 30. So you can't use this one. You need the standard normal distribution table, which is this one. So I'm showing you how to read the standard normal distribution table. You are locating this this value 0.005.
Sir.
It cannot really engage me closer to that.
Hello, sir. How about this one where there's 2.5 and 0.04?
Okay. There is 2.5 and the
2.5 and 0.4.
0.04 one is way higher. You've seen it.
Sorry?
At least one where there is 0, which is
yeah, breaking.
This one. I am saying that this one, which is in the line of 7, is closer because this is 0.0051. Have you seen that?
Oh, not the 0.005. Oh, okay, I get it.
0.0055. That would be to be too higher. So you can get an approximation of this one, which is closer. Are you able to follow? Like, are the people
Okay,
following
good.
how we are getting this? So these are the alphas that we're getting, the significance levels. All these numbers that you're seeing, they are giving us the different significance levels. So the areas of different significance levels. So we are saying that for this one, at least we find the area where there is 2.5 plus what? Plus 0.07, right? Isn't it? When you add this,
Yes, sir.
when you add these two, this one on the Z side plus these ones on top, like this 0.7, it should give us 2.557, right? As our critical value. Are you following? Yeah, I'm willing to get as many questions as possible here. Like, you can ask the questions. Are you fine with the way how you read the Z score? So let me give different alpha levels so that you maybe you understand. Let's say alpha now is equal to what? Is let's say it is what is the significance level? 5%, right? Let's say 5%. Our alpha is 5%, right? 5% is same as 0.05, isn't it? But if you divide this alpha by what? By 2, this will be 0.025, isn't it? Hello? Yeah, I'm trying to change the different levels of alpha so that you get conversant with this table. Are you able to see what we are doing now?
Yes,
so
sir.
alpha over you divide this by 2, it will be 0.025, right? So now let me show you how the critical values that you are going to get. Okay, number one, if alpha was let's say alpha was double tailed. If alpha was double tailed, you get this 0.025, isn't it? That would be your alpha, right?
Yes.
Yes, this would have been your alpha. So how do you get the critical value for this area now? I'm teaching you how to get the critical value for this area. You go to the table and you look for this area. Where do you find this area? Let's look for it.
2.8.
0.2.
Where there is 2.8 and 0.1.
Remember, this is 0.25. Where do we get 0.25? This table does not write that 0 point something. It just write point. Just know that before the point there's 0. We are looking for where there is 0.25 or 0.25. 0.025. Where do you find that one?
What of 1.9?
1.9.
1.9.
1.9 and 0.06.
Have you seen that time?
Yeah.
1.9 and the 0.06. 0.06. So we can add this now to create the critical value. Say 1.9 plus 0.06. The critical value will be 1.96, isn't it? So it means that the critical value at 5% at 5% significance level for the double tailed, it is what? 1.96. Clear?
Yes, sir.
Don't worry,
Yes,
you will
sir.
understand. You will
Following, but
understand.
not very clear.
No,
Sir.
it will be very clear. It will be.
Sir,
Yes,
sorry,
madam.
sorry to take you back. I don't know if it was Madam Chisha that was asking about the tables, but you mentioned something to say that for the T distribution critical values, you mentioned to say this one you need to use it when the I don't know the word you used, but you said 30% and less.
When the sample size is less than 30, that's when you use the T. It just works like a Z. I'll look for the example before the exam. We'll do all those things. I'll look
Also,
for the
we
example
haven't
that is
yet
specific.
done.
No, we haven't done
Okay.
that.
Okay,
Yeah.
sir. All right.
Just follow like what I've
I
saved
thought
you
I was
today
behind.
and get what no. Just get what
All
I've
right.
saved you today. You're fine.
Okay, sir. Thank you.
Don't panic very much. Yeah, I'll be giving you examples according to to the concept that I want to deliver. So now, as for today, I want just to talk about the Z value and the confidence level, and yeah, that's what I want to talk about. So that's why I'm giving you this. So, any question? Okay, now let's say I want you to get this so that next time we are not stuck. Because I know people had gotten cognizant of that half one, where you add 0.05. You remember that one, then you go in an exam or in the test, you find this one again, then you stuck. Yeah, anyways, I want you to be confident with how to read both of any of these tables. So now, like as for now, let's say now it is not double-tailed, right? Divided by 2. Then your alpha will be 0.05, right? So my question is, if alpha is 0.05, if alpha is 0.05, what will be the significant, what will be the critical value? What will be the critical value? We are looking for where there is 0.05 on our group. Where is 0.05? Check for 0.05.
2.5.
That's what I mean.
2.5 plus 2.5 plus 0.07.
0.07, 2.5 plus 0.07. But this is, Basa, this is 0.0.
5.1. That's the nearest. Eh? Okay.
These are 2 zeros. Check, there are 2 zeros, but we are looking for 1 0 before the decimal.
Okay.
After the
Okay.
Friends, let's look for 0.5. Where do we find the 0.5?
1.6.
1.6, comma what?
1.6, 0.4.
Yes.
Okay, you've seen that it is closer, right? 1.6. 1.6, let me use the red mark. 1.6, comma what? Comma 4, right? It's closer. Okay, it is closer to that. Okay, so it means you say 1.6 plus what? 0.04, which should give us 1.64, right? Hello? Okay, are you fine with how we get the critical values?
Give us another example.
Right. So, okay, I think we are fine now how to read this table. We no longer have challenge, right? We are now fine. We are fine. So now going back to what we had. We established that, hello? Is that a question?
Yes, yes. I wanted to find out.
Yes.
For this state, you mentioned we only use it. No, you actually didn't mention when we use it. You only mentioned the other one that we use it when the sample size is less than 30.
Okay,
So
the opposite is true. All right, sorry to cut you short. The opposite is true. When the sample size is 30 and above, you use this one, the standard normal distribution. Okay. 30, once the sample size is 30 and above, you use this one. But if it is less than 30, you use the T. They give the same answer, the same answers, of course, the required answer. Oh, sorry. I mean that they don't really give the same answers. Yeah. What will happen is that the T table will give you the expected answer when the sample size is less than 30, in short. Did you get that? Hello?
Thank you.
All right. Okay, now
excuse
I think
me, sir. Excuse me, sir.
Yes,
yeah,
sir.
we seem to be getting disturbed with the feedback. Someone has got the mic on.
From
we
here.
need to be helped. I don't know whose mic is on.
I'll locate who is this. There is silence now in the lounge. Okay. All right. So now let's go back to the question. We have established that it is 2.5 what? 2.57, isn't it? 2.57, that's our critical value. The confidence interval. So going back to the question, when we go back to our question, page 248. Okay. Page 248. Which question is that? Oh, 248. 248 is here. Oh, okay, it's here. All right. So now we have found our mean. We are putting in this one, mean plus C minus C. The critical value we have found it to be 2.57. Let me write the formula first. The Z alpha over 2, standard deviation over the root of N. So the mean is what? We said it is 154 plus or minus C. This critical value is 2.554, right? Multiplied by the standard deviation is what? Is 20 over the square root of 170, right? Over the square root of 170. Can we work out this? Okay, let's start from 20 divided by the square root of 170. From your calculators, I don't have a calculator where I am. 20 divided by the square root of 170, then that answer multiplied by 2.57 should give us that answer. I write it here.
Yeah, it will give us 3.942.
3.942. All right.
42.
Okay. So now look at this. This is the what you call the standard error Okay, this is the standard or error or the margin of error. So now, when you are creating the interval, it means that when you want the lower value here, this one, the lower value, you just subtract 154 minus this value. Okay, what is 154 minus this value? What do we get here as the lower value? It's 1 what? 150 what? We are minusing first.
150.
150.
0.058.
0.058. Okay. Can you add now that value like 3.94542 plus 154? What do you get?
One 157.942.
157.942. All right. So now this is the range. Okay. This is what we call now the confidence what? The confidence interval. This is the confidence interval at 99% confidence interval. You have created the interval. Is that clear? That's how you create the interval. Very easy. So now, doing question number 3 is related to this one. It says, use the confidence interval to determine whether the manager's claim is valid. In short, can you test the hypothesis using the confidence interval? This is confidence interval. Now listen carefully. How you test the confidence, you test the validity of the statement using confidence interval. You just check if the hypothesized value mu falls within this this category. Okay. If it falls within this interval, you fail to reject the null hypothesis. But if it does not fall within this interval, you reject the null hypothesis. So check, is the mean mu falling within this range? What's our mean? Our mean mu, like this population mean, that's the hypothesized mean that we're talking. It is 150. It is 150. 150. So does 150 fall within this range?
Does.
Yeah. So if it falls, then we fail to do what? We fail to reject, right? That's the conclusion. Like we fail to reject the now what? The now hypothesis. So fail what? Fail to reject the claim, okay, which is same as the now what? The now hypothesis. That is the conclusion. That's how you test using the confidence interval. We have failed to reject the now hypothesis because this value falls within this what? This range. Is that clear? Hello.
Yeah.
Okay. Then, in the last few minutes that have remained, I've shown you how to use the confidence interval. Let me show you how to use the z-value. The z-value is very straightforward since we already have the critical value. The critical value is already... Yes, madam.
Sorry, before you go far, I think I'd stopped listening when how you arrived at 2.57, but the other figures I have on my book, just go back on how you got the 2.57.
Oh, the two, but did you follow how we were extracting? We got it from the table because we got it from the table when we were saying our alpha is 0.005. Did you get this point? And have you followed when we were how to read that table?
So I followed everything. I just stopped listening what the 2.57 came about, but everything I have on my book.
Okay. If you have followed it, then we have gotten it from the table. Okay. We have gotten it from that statistical table. We just checked where there was 0. What? There was 0.05. We checked like you we got the number that was here. It was 2.5. They were meeting this value here, 0.005 was somewhere around here. Okay. Then it was meeting at 2.5 and 0.07 here. We added 2.5 plus 0.07, which was up. It gave us 2.57. Did you get? By the way, the class is being recorded.
Okay, sir. Thank you so much. I've gotten it.
All right. All right. So now let me show you how to use the Z value. So the Z value method now to reject it, or how do you make decisions? Now we are just testing the claim using the Z value. So we're given that X bar minus the mu over the standard deviation divided by the square root of what? The standard of the sample, like that. Okay. This is the calculated Z value. All right. It is called the calculated Z value. You need to calculate for the Z value now. You calculate. Then this calculated Z value, you will compare it with the what? With the critical Z value. That one we get from the table. We got the Z value from the table. That was 2.57, isn't it? That one, that critical value I was talking about is a Z value that comes from the table. It's a critical value. So can we calculate the one for calculating now, not the one you get from the table? So for calculating, you use this formula. What is the X bar? Our X bar is 1.154, isn't it? 154, which is the mean from the sample, minus the mu. Our mu is 150, isn't it? Divided by the standard deviation 20 over the square root of 170. What is 154 minus 150 is 4, right? Divided by, so what is 20? What is 20 divided by the square root of 170? We want to get the calculated Z value.
$13.03.
13.0
Okay. No. No, just
20 divided by the square root.
1.5339.
339. So can we divide this number now into 4? What is the answer? What is our Z value? Which is the calculated Z value?
2.6077.
3.6
2.60.
or 2.6?
Yes, sir.
2.6
077.
077. Okay. All right. 2.6. Are we getting the same, all of us?
Yes, it's the same.
Okay. All right.
Which is the same with the one that we got from the graph, because if you round off the 2.57, you get 2.6.
You get because we're rounding off these figures, you know. We need to try by all the means, maybe to round off to 3 decimal places so that we're not mixed up. Because basically, if we didn't round off, like we should be rounding off to at least 4 decimal places, not only to 2. Because once you round off to only 2 or 1 decimal place, you're reducing the accuracy of the answer. Okay. Because it cannot just be equal. It can't just be equal. It has to be a little bit less than that. It should be less than that. So how you use this one now? Anyways, how you use this one? How you use this one? We know that this Z, was a critical what? Was a critical Z, isn't it? It is the critical Z, meaning it occupies such a position like this one here. All right. So how you compare? How you compare is like this now. This is how you compare. If you look at this value, okay, this calculated Z and this critical Z, this one is a critical and you get it from the table. You compare them. Which one is greater than the other? Okay, you compare which one is greater than the other. Is that all right? You compare which one is greater than the what? Than the other. So you find that in this case, okay, you found that this one, which you have calculated, right? The calculated value is greater than this one, isn't it? Right? It's greater. The calculated value is greater, which means it falls in this region, right? It is after this one. It falls in the what? In this region, which is the rejection what? Rejection region. I should be able to highlight quickly that it's only that this question was not designed to use this what? This Z what do you call it? The Z value. Okay, that's why I think they specified that you use the confidence interval. They knew that it was not designed for that specifically to. It was not designed for the Z score. Because if it wasn't, it was designed for the Z score. What would have happened is that what you should do, the decision that you should make it during the confidence interval, actually, it should be equal. It should be the same here. You are following, right? If the normal question that is made specifically for that comes, you find that the decision that you make during the confidence interval has to be the same with this one. So during the confidence interval level, during the confidence interval, we failed to reject. We did not reject, right? But you find that here now, since this number seems to be bigger than that, it will mean that we are rejecting the null hypothesis because it is falling in the what? In the region that is in the rejection region, in short. But once we find the question that is created specifically for that, I'll give you such questions specifically. You find that the decision that you have to make here, there should be some consistency in terms of the decisions. But the message that I wanted you to get is just how you make a decision and how you calculate. That's all what I wanted you to get. In short, you need to get this critical Z that you get from the table. You compare it with this one which you are calculating. I've shown you how to calculate. If you find that this is greater, it means it is falling in the what? In the rejection region. If this was less than that, meaning it was going to fall in this what? In the fail to reject region. Or others call it the acceptance region. Any question? Hello?
Sir,
Madam.
sorry, I'm not so clear on how you come about on the conclusion as a researcher, like how to make it,
Okay.
how
The
significant is
conclusion.
your claim, like, yes.
Okay, so
Just
you compare these values, okay? You find that there is this critical Z that you get from the table, isn't it? Plus this one which you calculate from the formula, that formula which was X bar minus mu, right? Over the
yes.
standard deviation, like, yeah. You compare these two.
Mhm.
If you find that this one which you have calculated falls to the right of this, meaning it falls in the what? Rejection region. It's greater. Like 2.6 is greater than 2.5. So it falls in the rejection region. So if you find that this calculated value falls in the rejection region, it means you reject the now what? The now hypothesis. Your research is significant. But if you find that it is less than that, meaning if it were less than 2.5, it could have fallen in this acceptance region, which is the fail to reject region. Then you fail to reject the now hypothesis or the claim. Did you get that?
Yes, sir, I did.
Mhm. Okay. Any question? We have just done one question because I was teaching using one question. Hello? Hello? Okay. May the co-host stop recording the class then?